0.58. Okay, let me make sure that I'm looking at the numbers on that correctly. So
put it in as well. Okay, so
the right of the one and left of the other. So
it's just the outsides, right?
yeah. Wait. I'm like, I want to make sure I didn't do it wrong. Right of the positive number. Okay, yeah. Yes, so it's the outside ones.
Right, so, left, round your answer. Okay.
Yes, and so my answer, what I'm seeing on here is 0.1745.
Okay.
So
yep, we round it to 3.
Yep.
0.175.
Yep.
All right, number 4. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer. All right. As more extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
Okay.
Oh my gosh.
Probability that this, so it's the value minus the mean divided by the standard deviation, right? So we do the value is 177.6, correct? Am I putting that in as the right value?
That's the mean.
Is that the mean? Is that was not the population mean though? That was the
sample mean was determined to be 177.6.
Right, so that's X bar, correct? So.
All right. Sorry, what did you say?
Hold on. Let me just look here really quick and see what I'm doing.
The weights of the run.
Value. So the sample mean. Okay, so but they're saying the mean weight of passengers in commercial boats. So their standard, their U number is 185.
Okay.
And their X number here, so X a bar number is 177.6. And then the standard deviation
is 26.7.
26.7.
And then it's divided by the square root of n.
48.
48. So now I get to get my calculator out.
All right.
Okay. Minus 7.4. Okay, 48, and the square root of that is 6.923. 26.7 divided by.
Right, so I get a negative number.
Is that negative 1.920?
Yes. That's what I got.
Yes. Sorry, I'm still doing calculating, but so anyway, I'm just a mess. Oh, there we go. That times 1.918. Yes?
1.920.
Okay, yeah, perfect.
And then
and I'm putting that in the normal probability applet. 1.920.
Because we want to look at everything
All right, let me read the question. Find the probability that random will have a weight that is as extreme or more extreme. So means that we're not only interested in values that are lower than, but also as far away from the means as ours in the positive direction. Yeah.
So are these just the right and the left?
Right and left, I'm thinking, is what they're asking for. So
Because
for
that's
me,
the furthest away.
yeah. So my answer, I have a 0.0549. Is
Yes.
that what others got?
You just put it to 3, 0.55.
Yep.
0.055, sorry.
0.055, yes.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means, this cannot be determined from the information given.
I think it's going to be the distribution of the sample means. Because with individual observations, you're always going to see big variations, but if you look at a bunch of different averages, you're not going to see as many changes. So the standard deviation is going to be smaller. Does that make sense? Is anybody else thinking I'm totally whack?
No,
which one did you say?
Number 5, I was saying the distribution of the sample means is what I think is going to be the smaller, going to have a smaller standard deviation.
Yeah, that's what I thought too. The distribution of the sample means that second one with the little thing on top, right?
Yeah, the X sub bar or whatever. I say sub bar, but anyway. Okay, number 6. Which of the following results implies that the spread of whatever decreases as the sample size increases?
well, that's
the law of large number, I think.
Law of large numbers, because as we, I think that's, well,
I know that the standard deviation decreases.
With the law of large numbers? I thought with the law of large numbers, you're talking more about the population mean gets closer to...
Which means the standard deviation
well...
increases,
yeah.
right?
Well, the standard deviation gets smaller, but the X bar gets closer to what we're seeing in the population mean. So I think...
So the law of large numbers describes what happens to the spread of distribution of sample means on the sample. Yeah.
Okay, yeah, you're right. All right. So
what did you say for 6? The law of large numbers?
I did say law of large numbers.
Okay, that's what I'm
hoping.
Okay. Me too. And you know, if we
That's
get right. We'll survive if we get one wrong, right? We will be okay.
All right. This Winsome, you want to read number 7?
The scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8, a standard deviation of 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of GRE. What is this z-score corresponding to Diane's score? Round your answer to 3 decimal places. I have 1.045.
Oh, you've already done it? Wow.
Yeah.
Good for you.
I don't know if it's right.
150.8 divided by 8.8. What did you have?
1.045.
160 minus 150.8 equals divided by 8.
1.045, is that what you said?
Yes.
1.045 is what I get.
All right, that's what I got.
Okay. All right. Probability. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So, z-score again. And we just go to our normal probability applet. Put in.
So you just put that in the app, right?
Yeah, that's what I'm doing.
Have above, greater than. Yeah.
Greater than. So you just do the portion to the left of our z-score, or I mean, sorry, to the right of our z-score, which for me says 0.148.
Yes, that's what mine says.
Yeah, I got that.
So.
All right, a random sample of 5 students was selected. Their scores were this. What is the G-score? So we have to find the
means of that.
So what do you do? Should we add up all of these? I didn't understand this.
Yeah, I would add them all up and then do the average of those, because we're basically just finding a sample means.
Okay.
Sample distribution of means.
So you just divide it by 5.
Mm-hmm. And that for me was 160. Did anybody else get that?
I got 130.
Okay, let me do mine one more time.
$160.
Yeah, I got 162. So, or 160, not also,
okay.
not 2.
Okay, so what is the z-score corresponding to the sample mean? So we have to, of these students' scores.
So we have to do the 160 minus 150.8 divided by, sorry, I'm talking out loud while I'm doing it, and we had 5 students, so.
Divided by, what would be
square root of 5, right?
5.
So this equals 9.2 divided by 5.
Is that 1.84?
Sorry, it's taking me a minute to do my stuff. 2.236. Okay.
That's what I got.
Divided by 2.236 equals k1 over x times. I have 2.337. What did you guys get? And it could be that my calculations are wrong.
Well, what did you do? You did 160 minus 150.8 divided by 5?
No, I did it divided by 8.8 divided by the square root of 5. Because I did, you know how you have to use the standard deviation of theirs plus the square root of the n number. So.
Yep. All right.
Does that make sense?
Yep.
Yeah. So where's that question?
So 160 minus 150.8. 5.2. Okay.
Okay, divided by 8.8 and then the square root of 5.
Yep.
Um, 2.338.
I do, yeah, 2.338 is what I have. So I'm going to put that in on the probability applet for the next question.
We'll have a mean score greater than, so greater than that.
4 decimal places.
8. So do you have 0.010?
I have 0.0097.
Oh, they said you could do 4 decimal places. Okay.
All right, should we move on? How's everybody doing?
Not yet. I'm still trying to. So you do 160 minus 150.8.
Right.
Divide by 8.8, and then divide by the square root of 5, right?
Right.
So
Well, you want to do that first, the 8.8 divided by the square root of 5, and
right. And then do the next set of numbers. It's kind of, there's multiple.
because I do the 160 minus 150.8, and then.
And what did you get for that?
Oh.
What did you get for that?
And then I got 9.2 for that.
Okay. And now do the 8.8.
9.2 divided by.
Just do 8.8 divided by the square root of 5.
You kind of almost have to do those numbers separate because there's too many division portions to it.
It's like the.
Because I got 2.337. I don't know.
Yeah, that's it. 2.338.
Yeah, 2.33. We round to 3 decimal place. 1, 2, 3. Okay, 2.338. Okay, yeah.
And then if you put that in the normal probability applet, the next number you're going to get is 0.0097.
You have to do greater than.
Greater 2.338. And then what did you get? 0.0194?
I had 0.0097, so make sure that the only part of your normal probability applet that's shaded is just to the left, or to the right. Only the one little section to the right.
2.338.
So really quick, Gary, if our z-score was a -2, would we? And it said greater than, would we?
Do all the, so you'd put the -2 in on your left-hand side, but then you'd shade everything to the right of that.
Okay, that's good to know.
So that is 0.0097.
You got it. Good job.
Okay. And then what did you say about the?
Oh, we were just talking about on that normal probability app. If they ever ask you, like if the question says, let's say that z number was negative 2.338, and they said, what's the probability that they'll have a greater number than that, or whatever, there'll be a greater, anybody has a greater number than that, then you would put your negative number in on that left-hand side, but you're going to shade everything to the right of it.
Okay.
So it would be a big, huge number, right? It'd be like, I don't know, whatever, 993. So it would be a really big number. But that's just kind of looking at that greater than or less than helps you to kind of look at how you're going to use that probability applet and how you're going to.
Because that's my problem. Sometimes I don't understand how to use it.
Right. I always go back and I look at the question. When I start to get the normal probability applet, I put my z-score in, and then I go back and I look at the question one more time to see exactly what they're asking me for, and ask if they're asking me for greater than or less than or between two, so that I know where I need to shade.
So if they're asking for if it's greater than, you shade everything that's on the right.
That's right.
And if they're saying if it's less than, you shade everything on the left.
That's right. And if they're saying between this number and that number, if they're saying if they're saying between this number and that number, how many had between this number and that number, then you're going to shade the middle section. But if they're saying how many have less than this but more than that, then you're going to shade the outer sections.
Okay.
All right? All right, so I'm looking at this question, and number 11, it says, what's the shape of the sampling distribution of random variable x, which represents the sample mean of 81 students who are selected? And because it's a big number, I think it's going to be an approximately normal shape, was my thing on that. So, okay, so the mean of the distribution of the sample means for all possible samples of size 81 could be drawn from the parent population. So, mean of the distributions. Let's see.
All right.
0.5 and O is 0.7. So, I think that's going to be the same number, right? Because it's the mean of the distribution of the sample of means for all possible sample sizes.
It's just 3.5, right?
Right, that's what I'm thinking. But this, and then the standard deviation of the sampling distribution of the random variable x. So now that's going to be a different number, and that's going to be that standard deviation number divided by our square root of the sample size.
Yeah, which is 9.
Right. 0.7 divided by 9 equals 0.07. How many decimal points do they want? If the answer's, okay, they want 3 decimal points. So
I swear this was on the, this is the one I just asked you.
So the standard deviation of the sample distribution of the random variable x, the mean of 81 students who was, okay, so for me, I had 0.078.
What number is that?
Number 13?
Yep, so number 12 is
Yes.
the GPA of 3.5, and then number 13.
Yes, I got that. 0.078.
Right. And then probability of the mean GPA for 81 randomly selected, okay, less than 3.3. So this is one of those ones you get to figure out that z-score. 3.3, 3.5 divided by 0.7 divided by the square root of 81.
5 divided by 0.0. No, divided by
3.3 minus 3.5 equals divided by 0.07. See. Minus 2.5.
2.71. 2.71.
And then what are they asking me? I mean, less than 3.3. So that's 0.0052. Probability of mean decrease.
The negative 2.571, right?
Pardon me, I had negative, what was that?
So it's less than the z-score of negative 2.571. Is that what you have?
I have 564, but close enough. And so my number was, my probability number was 0.0052.
All right. And you're only putting rounding to the...
Yeah, 0.005. So.
0.005.
probability mean GPA for 81 randoms will be greater than 3.3. So then we just change the applet shading.
And so this is where you do both of them.
You do both of them, the whole middle section and then the end section as well. So I had 0.993.
That's number 14. What was how did you work that?
Number 14. Hold on, let me. Okay.
So you want to take your 3.3 minus 3.5 divided by that standard deviation that you figured out, which was 0.077 or 0.078.
0.078. And that was, and then I ended up with the number negative 2.564. And so when I put that into the normal probability applet and I just did the numbers that were less than, which was just shading to the left of that. Did I say left? Yes, left. And I got 0.005. And then for the second question, we just unshade basically that left side and shade all the right, and we get 0.995. And I submitted my answers and got them right. Woo! Yay!
What did you put for 9, number 9?
Number 9, I put 2.338.
Okay.
Did you get it wrong?
Yeah, I'm going to have to redo that one.
Oh, I'm sorry.
That's fine.
Can we do these ones again? Are we allowed to do these quizzes more than once?
I don't think so.
Oh, bummer. I'm sorry.
Oh, yeah, I don't care. That's better than, I mean, I did the homework and I got a C minus, so now I got to go back and do.
Oh, I'm sorry.
But I do want to ask you.
Yes.
That one question.
Yes. And if you may want to stop the recording. Okay.
All right.
So, anyway, but yay, done with that.
What did you put for number 10 again?
For number 10, let me look on mine really quick here.